Today, we're going to be talking about matter and its classification. We have one essential question and one real objective. Our essential question, or our EQ, is what criteria do we use to determine the classification of matter that a substance belongs to? Our objective is to be able to identify and describe the particle arrangement of the three states of matter as well as the phase changes. So let's begin with the basic question. What is chemistry? Chemistry is the study of the composition of matter and the changes that matter undergoes. Matter, then, is anything that has mass and occupies space. We call that volume. Mass is how much stuff there is in something, which isn't necessarily the same as weight, but can be considered very similar for our current purpose. And volume is the amount of space that something takes up. So, are these six items that we see on our screen matter? Why or why not? Is grass matter? What about chalk? Would you say that light is matter? We're talking about sunlight or artificial light. Would you consider your ideas matter? What about the air that we're breathing right now? So now that we've discussed whether or not the things that surround us are matter or not, let's talk about how we classify things as matter. Matter can be classified in two ways. The first is its state, and this is probably what you guys are most familiar with, whether something is a solid, a liquid, or a gas. The second way we can classify matter is by its composition. So, what exactly is this item made out of? Let's break that down even further. Let's talk about how we classify things based on their state. Something is a solid if it has a definite shape and a definite volume. What that means is that its shape and its volume are fixed. They're not likely to change. So, for example, your cell phone. Your cell phone has a definite shape. You can't change its shape by smushing it or pushing it down. And it has a definite volume because you're unlikely to be able to add anything to the phone. A liquid has an indefinite shape but a fixed volume. So a liquid will take the shape of whatever container that it's poured into. So, for example, if you poured a can of pop or soda, I'm sorry, into a cup, you would see that it would take the shape of the cup, but its volume, how much of it there is, remains the same no matter what container it's in. And gas has an indefinite shape and an indefinite volume. It will take the shape and volume of the container that it's in. If you were to fill up a balloon with helium, you would see that as you push the helium into the balloon will begin to expand. That is the gas molecules, the helium molecules, taking up the available space inside of the container. Here's a pictorial representation of what that looks like. In our solid state, the molecules or atoms are very closely packed together. They don't have a lot of space to move. In our liquid state, they are a little more free, a little bit of space to bump around here, but still not as much as what we see with our gas state. Lots of free space. These molecules tend to bump into each other and then repel each other rapidly. So matter exists at different phases that depend on its kinetic energy. And kinetic energy is what we call the energy of motion. Temperature is the measure of the average kinetic energy. So as we heat up a substance, the molecules inside of it begin to move faster. Okay? And as the molecules inside of it begin to move faster, you'll notice that a substance that might have originally been solid may begin to take a different state. And if we continue to apply heat, then our solid that is now a liquid might even begin to transition into another state of matter. That should sound very familiar to you all if we think about the phases of water. When water is frozen, aka it's very cold, its molecules are densely packed together and don't create a lot of movement or friction. This is why our ice cubes are solid. When we take our ice cubes out of the freezer, and if you were to put it in a glass of water or even just leave them out on the counter for some reason, they'll begin to melt as they adapt to the temperature of the room. The temperature of the room is warmer than the temperature of the freezer, and so the molecules loosen up and begin to pull away from each other. They have more space to move around. If we were then to take our melted ice, which is now water, and place it into a pot and put it on the stove and begin to boil it, we'll notice that steam will begin to rise. And if you leave it to boil for too long, all of the water inside of the pot might evaporate. That's because even more temperature has been applied to the liquid, and so its measure of motion, its energy of motion, has increased to a speed that allows for another conversion. Okay? Great. So, quick check for understanding. Which state of matter has the fastest moving particles? These different spaces as solids being a group of friends who are outside and it's very cold, and so they huddle up together. And then as it gets a little warmer, they can separate. And finally, it's a hot, sunny summer day, and you definitely don't want to be too close to anybody right now. So, quick check for understanding. Which state of matter has the fastest moving particles? And as you heat up a substance, what happens to the particles? Which state of matter has a definite shape and a definite volume? State of matter has particles that are very close together. So we know that states of matter can change between one another. These physical changes have special names, most of which you are probably already familiar with. If something turns from a gas into a liquid, we call that condensation. So if you've ever noticed sweat beading up on the outside of a very cold glass of water, that's gas turning into a liquid. Liquid turning into a solid is called solidification. A solid turning into a gas is called sublimation. And then the reverse of that, a gas turning into a solid is called deposition. A solid turning into a liquid is melting. And a liquid becoming a gas is evaporation. Let's move on to the second way that matter can be classified, by its composition, also known as what it's made out of. This is a states of matter flowchart. We can see several different states of matter and how they exist. At the very top is all matter, solids, liquids, and gases. That section can be divided into two subsections, pure substances and mixtures. Pure substances can be physically combined to form mixtures. Pure substances have two categories, elements and compounds. Elements can be chemically combined into compounds. Elements can be chemically combined into compounds. Mixtures also have two further subsections, homogeneous and heterogeneous. Homogeneous mixtures are soluble. Heterogeneous mixtures are insoluble. Soluble simply means that something can be dissolved, typically in water. Soluble means that something can be dissolved, typically in water. So homogeneous mixtures have the ability to be dissolved, usually in water. Insoluble mixtures are impossible to dissolve. Insoluble means impossible to dissolve. Let's discuss these different states of matter in further detail. Pure substances are things that have a specific chemical formula. They are made up of specific atoms of elements from the periodic table arranged in a specific way. So here we see atoms from elements of the periodic table. We have oxygen, hydrogen, carbon, nitrogen, chlorine, and fluoride. And here we see different combinations of some of these atoms arranged in very specific ways. Compounds are made up of more than one atom in a specific chemical formula. So, for example, water is always made up of one oxygen atom bonded to two hydrogen atoms. One oxygen atom bonded to two hydrogen atoms. Elements are made up of one atom alone. So, for example, the substance gold is made up only of gold atoms found in the periodic table. Let me clarify that and say that elements are made up of one type of atom. Impure substances are also called mixtures. Mixtures do not have a set chemical formula. They can include atoms and molecules combined together in a random format. They may appear the same throughout, or they may look different. So we have two types of mixtures. Our homogeneous mixtures, which are also called solutions. Homogeneous mixtures look the same throughout. The particles don't settle out, so you can't differentiate or tell the difference between the particles that make it up. An example of this is apple juice. So apple juice is a mixture of sugars together with different acids, tannins, vitamin C, minerals, and several other things. But when you look at a glass of apple juice, you don't see all of those different things in its mixture. You simply see the apple juice. A heterogeneous mixture is a mixture that's made up of different particles that can be easily distinguished from each other. An example of this is like a fruit salad. In this picture here, to the right, you can see strawberries, you can see cantaloupe, you can see pineapple, blueberries, etc. Lots of different particles that you can easily tell from one another, and if you wanted to, that you could take apart. So now we're going to take about 6 minutes and we're going to classify the pictures below with a partner. You have four groups that you can place these items into: elements, compounds, homogeneous mixtures, or heterogeneous mixtures. Your time begins now. And that's our time. Now, let's discuss your choices. Those are some great, well thought out responses. Now, let's go even further. Just a quick reminder. So, pure substances are constant compositions with distinct chemical properties, i.e., elements, which are the simplest form of matter that have a unique set of properties composed of identical atoms found on the periodic table. Examples include sodium, Na, potassium, chemical symbol K, and Au, which is chemical symbol gold. Compounds consist of two or more elements that are chemically combined. Examples include H2O, which we know as water, CO2, which we know as carbon dioxide, and NaCl, which we know as sodium chloride or table salt. So pure substances are either elements or compounds. Examples of pure substances that are elements include copper and aluminum, and examples of pure substances that are compounds include table salt and water. Mixtures are physical blends of two or more substances. Homogeneous mixtures have the same composition throughout, and heterogeneous mixtures, the composition is different throughout. There are visibly different particles. So to our left, we have a heterogeneous mixture. It is a rock. To our right, to our left here, we have a heterogeneous mixture. And to our right, we have a homogeneous mixture. Check for understanding 2. Answer these questions in complete sentences in your notes. Elements are made up of how many types of atoms? Compounds are made of how many types of atoms? And mixtures are made up of how many types of substances? Pure substances also conform to laws. In general, a law is the description of an observed phenomenon. It doesn't necessarily explain why the phenomenon exists or what causes it. So a law is a description of something that we've observed happening with pure substances. So the law of definite composition says that a given compound always contains the same fixed ratio of elements. Just as we know that water is always one hydrogen atom and two oxygen atoms, H2O. If the ratio is different, then that is no longer water. And they also conform to the law of multiple proportions. Elements can combine in different ratios to form different compounds. There's nothing stopping carbon and oxygen from gathering together as simply one carbon oxygen atom and one oxygen atom, which we would call carbon monoxide, or one carbon atom and two oxygen atoms, which we would call carbon dioxide. As we see here, one carbon molecule, one carbon atom, one oxygen atom form one molecule of carbon monoxide, one carbon atom and two oxygen atoms form one molecule of carbon dioxide. Although these are two different compounds with two with although these are two different compounds, each has a definite composition. There are 3 types of mixtures: solutions, colloids, and suspensions. Solutions are homogeneous, so they have very small particles. They don't exhibit the Tyndall effect, which means that light will pass through them. So this container here on the right, where the flashlight is pointed, the light is passing through this. So this is a pure solution. It's a solution, while whatever is in this container would not be considered a solution. An example of this is rubbing alcohol. Colloids are also homogeneous, but they have medium-sized particles, and they do exhibit the Tyndall effect, which means that light will not pass through this mixture. You can think of this like milk. The last type of mixture is a suspension. It's heterogeneous, it has large particles, and it also exhibits the Tyndall effect, meaning you're not going to be able to see light through the mixture. An example of this is fresh squeezed lemonade. So here we have some examples of mixtures. Mayonnaise is one, it's a colloid. Muddy water is another, a suspension. Fog is a colloid. Salt water would be considered a solution. An Italian salad dressing would be considered a suspension. So how do we compare compounds versus solution versus mixtures? I'm sorry. How do we compare compounds versus mixtures? Compounds have properties that are different from the elements from which they are made. Compounds have properties that are different from the elements from which they are made. You can also always write a formula for a compound. So, for example, the formula for sodium chloride could be written as sodium chloride equals 1 sodium atom plus 2 chlorine atoms, while mixtures retain their individual properties. For example, salt water is both salty and wet. In your notes, create your own graphic organizer. In your notes, create your own graphic organizer that looks like this. And take some time to compare and contrast elements, compounds, and mixtures. You'll have 5 minutes to do this. That's time. Let's discuss some of the options. So for elements, something that you could have placed is only one kind of atom. For compounds, you could have said two or more kinds of atoms and that they are chemically bonded. For mixtures, you could say that there are two or more substances, that they have a fixed composition, and that they are physically mixed. Similarities between elements and compounds include that they are substances with definite makeups and definite properties. And the similarities between compounds and mixtures are that they are two or more kinds of elements and substances. Let's check for understanding of the day. What are the differences between elements and compounds? What are the similarities between elements and compounds? What are the differences between compounds and mixtures? And what are the similarities between compounds and mixtures? In Canvas, please make sure that you've completed the Google Slide interactive sort, watched the video under U1L1, done the classification of matter practice, and also the student created flowchart.